Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us begin solving this step by step. Find X isomers of C8H10 that give only aromatic dicarboxylic acid with hot alkaline KMNO4. C8H10 has degree of unsaturation is equal to 2 times 8 plus 2 to 10, 2 is equal to 4, indicating an aromatic ring. These are alkyl benzenes. Possible structural isomers of C8H10. 1. Ethylbenzene, C6H5CH2CH3. 2. 1,2 dimethylbenzene, O-xylene. 3. 1,3 dimethylbenzene, N-xylene. 4. 1,4 dimethylbenzene, P-xylene. When treated with hot alkaline KMNO4, alkyl groups on benzene are oxidized to CoO groups. For only a dicarboxylic acid product, the benzene ring must have exactly 2 alkyl substituents, giving 2 CoO groups is equal to phthalic acid derivatives, or one substituent that gives 2 carboxylic acids is not possible from a single group. Actually, each alkyl group, regardless of length, is oxidized to one CoO group. So, ethylbenzene, 1 alkyl group monocarboxylic acid, benzoic acid, not dicarboxylic. O-xylene, 2 methyl groups phthalic acid, dicarboxylic. M-xylene, 2 methyl groups isophthalic acid, dicarboxylic. P-xylene, 2 methyl groups terephthalic acid, dicarboxylic. So X is equal to 3 isomers of C8H10 give only aromatic dicarboxylic acid. Moving on to the next step. Find Y isomers of C4H8 that give CoO2 with hot alkaline KMNO4. C4H8 has degree of unsaturation is equal to 2 times 4 plus 2 to 8, 2 is equal to 1, so 1 degree, either 1 C is equal to C, alkene, or 1 ring, cyclocane. Hot alkaline KMNO4 cleaves C is equal to C double bonds. CoO2 is produced when a terminal is equal to CH2 group is oxidized, i.e., RCH is equal to CH2 gives RCOOH plus CoO2, and R to C is equal to CH2 gives R to C is equal to O, ketone, plus CoO2. Isomers of C4H8. Alkenes. 1,1-butene, CH3CH to CH is equal to CH to CH3CH to CoO plus CoO2, terminal is equal to CH2. 2,2-butene, CIS-CH3CH is equal to CH-CH3 to CH3 CoO, no CoO2. 3,2-butene, trans-same oxidation products as CIS-2-butene to CH3 CoO. 4. Isobutylene, to methylpropene, CH3 to C is equal to CH2 acetone plus CoO2, terminal is equal to CH2. Cycloalkanes. 5. Cyclobutane, ring, no C is equal to C. Hot KMNO4 would not easily cleave to give CoO2 in standard conditions, cycloalkanes are generally resistant. 6. Methylcyclopropane, cyclopropane ring with methyl. Cyclopropane can be oxidized by hot KMNO4 but does not give CoO2 directly in a straightforward manner. Wait, let me reconsider. CIS and trans-2-butene are stereoisomers. The question asks for structural isomers typically, but they are counted as separate isomers in some contexts. However, for C4H8 structural isomers with C is equal to C. 1-butene. 2-butene, CIS and trans are geometric isomers, counted as 2 isomers, neither gives CoO2. 2-methylpropene. So Y is equal to 2, 1-butene and 2-methylpropene give CoO2. And for the final step, X plus Y is equal to 3 plus 2 equals 5. Therefore, the correct answer is 5. Therefore, the correct answer is 5.